All right, guys, so if you remember from the last video, we were talking about what were called polyhedrons as well as prisms, and we had the opportunity at the end of the notes to start finding the volume for prisms. Now, we only looked at rectangular prisms, so today we're going to look at other types of prisms. We're going to look at triangular prisms, we'll look at some trapezoidal prisms, and then we're also going to take a look at cylinders, which cylinders you can kind of almost think of as circular prisms, but cylinders is the more common term for what those are. So when you want to find the volume for any other type of prism besides rectangular, it's really kind of the same formula. You're taking your base, multiplying by your height. Now the area for the base, though, is going to be different depending on what type of base and what type of prism you have. Obviously, with rectangular, they were all the same. Take length times width times height. Now we're going to get into some different scenarios because not everything has an area that can be found by taking length times width. For triangles, for instance, that would be 1/2 the base of the triangle multiplied by the height. So a little bit different. So let's go ahead and take a look at some examples of this. Let's start actually with a triangular prism. So looking at this prism, let's identify its base as well as its height. You've got two different bases. I'm going to shade in the one that we're going to use to find the area. And then obviously you've got your height right here, which is 8 centimeters. So let's take a look at the area for our base. So for our base, since it's a triangle, we're going to take 1/2 its base multiplied by its height. Now notice that I use the lowercase b to represent the base for the triangle, as opposed to using uppercase B for the area for the entire base itself. Okay, so we already have the base, obviously that's 6 right here, and then the height for our triangle, since the 6 has a tick mark, we also know that this has to be 6, and that's going to be what we'll end up using for our height. So for the area for our triangle, for the area of our base, we're going to take 1/2 multiplied by 6 multiplied by 6, and when we simplify that using a calculator, we should come up with an area for our base which is equal to 18. So now remember that our volume for this particular prism is equal to the area for its base multiplied by its height. What we just found was the area for our base, which was 18. We're going to multiply that by our height for our prism, which we found at the beginning was 8. And then to find our total volume, we'll multiply those two numbers together. 18 multiplied by 8 is 144. And then remember, when you write your label, we call that centimeters cubed. So our labels will always have that exponent of 3 after them, as opposed to the exponent of 2 that we used when we were talking about area. Okay, let's do another example of this. So on this next example, we've actually got a trapezoidal prism. So again, what we're going to eventually find is we're going to use that exact same formula. We're going to take our area for our base multiplied by the height. So let's first identify the base. And for this trapezoidal prism, our base is going to be this area right here, which I'll go ahead and outline for us, would be this piece that I've got outlined. Which means that our height is actually going to be this 25 meters right here. So let's go ahead and find the area for our base. So the area for our base is that we're going to take the average of our two bases, so base 1 plus base 2 divided by 2, and multiply that by the height for our trapezoid. So looking at the values that we were given, 18 is going to be our base 1. 36 meters, although it was written over here, would also be the same length over here. That's going to be our base 2. And then our height got kind of covered up when we shaded this in, but that's going to be that 14 meters right there. So to find our area, we're going to take base 1, which is 18, plus base 2, which is 36, divided by 2, and multiply that by our height of 14. So as we simplify that, if you just wanted to simplify the fraction first, 18 plus 36 is 54, divided by 2 is 27. So everything inside the parentheses simplifies to just be 27 multiplied by 14, and then that's going to multiply to be 378. You could also just type everything into your calculator by the time you get to step 2, and then you would be able to get that 378 in one step instead of simplifying. But it's kind of up to you how you want to work that. All right, so now that we've got the area for our base, we should be ready to put that into our formula for volume. So again, the area for the base that we just found was 378 multiplied by our height, which we already knew was 25. And when we multiply those together, we're going to come up with 9,450, and then include our label, which is meters cubed. Okay. Let's take a look at 2 more examples of this, and then we can start to take a look at some prisms, or some cylinders, rather. All right, so once again, we've got a triangular prism. This would actually be a really good one if you're wanting to practice one on your own to be able to do that with. But if you want to continue working on it with me, I totally understand. Let's go ahead and take a look at it here. So once again, our volume is going to be equal to taking the area for our base multiplied by the height. So for our base, in this particular example, again, it's a triangular prism, so our base is going to be one of the 2 triangles. I'll just use this one at the bottom. And so then our height would have to be the 15 feet, which is the distance between our 2 bases. Okay, so let's focus on finding this area for our triangle. So the area for our triangle is that we're going to take 1/2 its base multiplied by its height. And as we look at this triangle, let's copy down some of the information. We knew that this length right here was 8 feet. That means that this length right here is also 8 feet. The problem is we also need to know what this length is right here. And we don't have that right now. So let's go ahead and find that. I'm just going to call that, let's call that x, and let's solve for x. In order to solve for x, notice that it is a right triangle, and so to solve for a missing side, we're going to use the Pythagorean theorem. So that would be that x squared plus 8 squared is equal to 10 squared. Simplifying that, we're going to get the x squared plus 64 is equal to 100. And then we'll subtract over the 64 to get that x squared is equal to 36. And then take the square root of both sides to find out that x is equal to 6. So that tells us what x is. In fact, I'm going to erase x and put a 6 there now. So now we know our base and our height are 6 and 8. So we'll take 1/2 multiplied by 6 multiplied by 8, and that gives us the area of our base, which is equal to 24. So we're now ready to finally go back and put all of that into our formula for volume. So the area for our base that we just found was 24 multiplied by our height, which we already knew was 15. And when we simplify that, we'll come up with our volume being equal to 360 feet squared. Well, feet cubed. Let me correct myself there. Feet cubed is what we should have had for our final answer. Okay. For our very last one, we actually have a cube. So we've got 5 inches as the length for one of our sides. And in fact, if that is 5 inches, then this is also 5 inches. This is also 5 inches. And for this one, thinking about the volume being equal to our base multiplied by our height, the easier way to think about this, since it would technically be the same as a rectangular prism, would be to take length multiplied by width multiplied by height, which is just 5 multiplied by itself 3 times, which is 125, and that's inches cubed. Okay, so let's take a look at cylinders, which is going to be a similar process, very much like a prism, but doesn't have lateral faces. So that's kind of the key difference. So if you look at our definition for a cylinder, it is two bases like the prism, but it does not have lateral faces. Instead, it's got that continuous curve that wraps around the circle. Now the formula is still the same. The volume for a cylinder is still that the volume is equal to base multiplied by height, where B is the area of your base and H is obviously the height between your bases. Now the nice part about these particular examples is that your base is always going to be the same. If you think about it, the area for your base, which is the area for a circle, is just pi r squared. So another way that you could write your volume for a cylinder would be to write it as pi r squared in place of base multiplied by your height. In fact, that'll end up being the formula that we'll use throughout today's notes. So let's take a look at just a few examples of it. I think we've just got 4 examples in total, and they should go pretty quick. All right, so for this first one, really what we have is 2 parts of information. We're told that our radius is 18, we're told that our height is 15, and those are all we need in order to find the volume for the cylinder, which again, the formula for that is pi r squared multiplied by height. So putting those into our formula, we're going to get pi multiplied by 18 squared multiplied by 15. And when we simplify that, multiplying out the numbers that come after pi, 18 squared multiplied by 15 is 4,860. Then we'll go ahead and put pi after the number rather than in front, and then include our label, which is inches cubed. All right, let's take a look at another example. So once again, we've got a cylinder here. We know that the height, even though it is not on the edge of our cylinder, it's in the center of our cylinder, it's still going to be the same. So our height's going to be equal to 8. But this time, we don't have our radius, we have our diameter, which is 10. And so remember, to get your radius, just take half of that. And so our radius is going to be equal to 5. So let's go ahead and find our volume for our cylinder. Again, that formula is pi r squared multiplied by height. And so as we plug those numbers in, we're going to have pi multiplied by 5 squared multiplied by our height, which is 8. And to simplify that, we'll multiply together the numbers after pi. So 5 squared multiplied by 8, which is 200. Then we'll put pi after it, and then include our label, which is meters cubed. All right. For this last one, we are going to have to do just a little bit of work in order to figure out what our radius is in particular. Notice that we have our height already. So our height we already know is 8 centimeters. But what we don't know is we don't know what the length of our radius is or what our diameter is. But it'll probably be easier to find the length of our diameter and then use that to find the length for our radius. In order to do that, notice that we've got, once again, a right triangle. And actually, once again, our hypotenuse is 10, and our length for one of our sides is 8. So if you wanted to, you could actually go back to the problem where we had to do Pythagorean theorem before, where we also had a length of 10 for our hypotenuse and a length of 8 for one of our sides, and we found that the length for our other side was 6. And so really we don't need to do very much work. We've already actually done this before. We should already know that our length for our diameter, this missing length, is equal to 6. Now, if you wanted to do Pythagorean theorem again, you could, but it's going to end up being the exact same thing. And then from there, to find our radius, just take half of that, which is 3. And at this point, we should be ready to go ahead and use our formula. So again, that was pi r squared multiplied by the height. So putting in all the information that we now know, our radius is 3, and our height is 8. In order to simplify, we're going to multiply together the two numbers after our pi. So 3 squared is 9, multiplied by 8 is 72. And then we'll put pi after it, and then include our label, which is centimeters cubed. All right, so now let's look at an application problem where we're going to most likely find the volume for our cylinder. So a diagram of Eric's pool is shown below. He plans to fill his pool to a depth of 4 feet with a garden hose that has an 80 cubic feet per hour flow rate. How many hours is it going to take to fill his pool? Okay, well let's figure it out for Eric. So taking a look at our cylinder, we know what our height is already. We already know that our height is this 4.5. And then for our radius, we know our diameter, which is 26. So remember, for radius, take half of that, which is 13. So the volume for Eric's pool, which we'll need to figure out first to see how much of his pool is going to have to be filled, is that we're going to take pi multiplied by r squared multiplied by the height. Again, we now know what r is. R is 13, so that's 13 squared multiplied by 4.5. Which, because this is more of an application problem, let's just go ahead and multiply all those together. Make sure to use the pi button on your calculator as you multiply these numbers. So that's going to be pi multiplied by 13 squared multiplied by 4.5. So as a decimal, what I'm coming up with here is that we have 2,389.18 as our volume for our pool. Now, that's our total volume, again, including pi as part of that. We want to know how many hours is it going to take to fill this pool. And we already know that it's going to fill up at 80 cubic feet per hour. So what we would need to do is take this answer and divide by 80, and that's going to tell us the number of hours, which is going to be quite a bit of time. It's going to take about 29.86 hours to completely fill his pool. All right, so I believe that's it, guys, for right now. In the next section, we're going to talk about volume for a couple more figures. We're going to take a look at pyramids, and we're going to take a look at cones. Until then, have a great rest of your day.